the mark scheme isn't entirely accurate, but
Okay.
if there's any ambiguity, hopefully we'll be all right. Okay, how about this?
There's a provide contradiction. So it says the product of two odd numbers is odd. Does that mean I need to write the statement as in like the product of two numbers is even, or
Yep.
and then if I say like, oh, if I say that m plus one is odd,
Mm-hmm.
and then if I say something like m plus one plus m plus one, which will give two m plus two, does that mean that have I then proven that that's contradicted?
You then have to show that it is even. How do you show that 2n plus 2 is even?
Oh, divided by two.
Factorize out 2.
Yeah, so two, and then that'll be yeah, m plus one. Yeah,
Yeah, it's an expression. If it was equal to something, you could divide both sides to keep both sides equal. But if you just half a number, it just went from being, 6 to 3. You can't just cut it in half. Then it's just a different number. Yeah, you factorize it out. And then how do you get the final marks at the end?
and then do I say therefore the product of two odd numbers is even, or is
Uh,
it too early?
so that'll be, yeah, very last thing you say is therefore the product of two odd numbers is odd. Um, and I think you have to say before that, like this creates a contradiction, or this contradicts our original assumption, something like
Yeah.
that. I can just get the exact wording. I'm glad you already know that stuff. It takes a long time to. There we go. To do those questions, they're not. So assume the opposite. There exists a product of two numbers that is even. 2n plus 1 for the odd one. So slightly different from your one. So you did have to factorize out 2. Let's see. Where there's two different numbers. Yes. So two consecutive odd numbers. Oh, any two odd numbers. So one is 2n plus 1, and then the other is 2m plus 1. Okay, consecutive would be 2n plus 3. You would just expand those, like expand either one of those, and then factorize out 2. Yeah, so it would expand out to be, let's say, oh well, their one is a general case. Their one is better. 4nm plus 2n plus 2m plus 1. Yeah, what would you get if you how would you show that that's an odd number?
Um, do I say that? So if I factorize, if I factorize out like the first three terms to two times, and then I say so that'll be even, but then if you add one, it'll become odd.
Yeah, exactly. And actually, that's what we were supposed to do.
Yeah.
It's odd. It contradicts our assumption that it's even. Therefore, the product of two odd numbers is odd. Yes, two different. Hang on, two different odd numbers. So we can't use n twice. We have to use n and m. Okay.
Yeah.
Grand. Okay. 2a.
Okay. So some of the first n terms is. Do I need to like start off some? Do I need to just make up my own arithmetic sequence series and then prove it from there or something? Or
No, 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 no.
yeah,
Um,
okay.
or maybe I think I understand what you're saying. So a sequence. What would you call the first term algebraically?
A
So a. Second term.
A plus D
Third term.
A plus 2D.
And you do that. Let's see. What would be the very last term?
A plus ND.
Let's see. It would be one less than that because there was no D at the end. And so it would be A plus N minus 1D.
Oh, yeah. Yeah.
Second last term?
A plus N minus 2D.
And actually, yes. Let us see now. What if you were to... there was some easy method. I have a more difficult method where you add the first to the last. They have some easy method where you multiply everything by 2, I think. You go like 2s, and you get 2a, 2a, 2d, 2a, 4d, and you factorize out 2, and then you do simultaneous equations and subtract them or something to get s equals. It's in the book. Let's see. Let us see. A plus D, A plus 2D. Then there's the last one. S equals... what is this space here? Attempts to add the two sequences. What two sequences? Oh, okay. No, well, I think there is an easier way. But they wrote the same sequence again, just backwards.
Okay, yeah.
So S equals A plus N minus 1D. So they did do the first plus last, second plus second last. And so what would you get if you added first plus last, second plus second last, and so
on? A plus N minus 3D.
N minus 3D. Okay, so you have to add the first and last.
So, is that like A plus N minus 1D? So that'll be, is that 2A plus N minus 1D?
So that is 2A plus N minus 1D. What happens to all the others? Do they all... you would you see all the n's?
Yeah.
You can factorize out all the n's. So that is 2s, and so 1s.
A half times N.
Yeah, or n over 2.
Yeah.
2a plus n minus 1d. So it's 3 marks. I just want to see 2a plus n minus 1d times n, and then that, and I'd probably just try to memorize the steps. They're in the book, arithmetic series proving the formula. But 3 steps are: write the sequence first to last. Essentially you add the first to the last, or you just write it again but in reverse order, last to first. Add the 2 together, factorize out n, and then divide both sides by 2. Okay, part B.
What is this? Where I need to do something like 1 plus 199 plus 3 plus 197 and stuff.
Okay, that'd be long.
Okay.
If only you had a formula for an arithmetic series.
Yeah, we do. So first 200 odd numbers. So is that like just? It's actually going to be like 100. So that's 100 numbers in total, isn't it?
I believe so, yeah.
So do I need to sub in 100 for n?
Yeah.
And okay. Oh, shall I first of all say, so is A going to be 1
Mm-hmm.
and D will be 2?
Yeah.
And so if I put all that into my calculator, so that would be 100. I got 10,000.
And have I gotten full marks for this question?
Find the sum of the first two odd 100 numbers.
I have not. You have to show what you put into the calculator.
Yeah, okay.
100 minus 1 times 2. Yeah, so just write down what you put into the calculator, and that's your method mark, 2-mark equation. Like n is 100, a equals 1, d is 2. Like maybe. No, I would say you would need to actually just show what you put into your calculator. And that's the compromise of using the calculator. 40,000. N is 200. Let me. It's not from 1 to 200. It's the first 200 odd numbers. Okay.
Yeah. So I'll just put in 200 instead of 100.
Yeah. Okay.
Yeah, 40,000. Yeah.
40,000. Great. Okay. There you go. Any questions about that?
No.
Okay. And if you get stuck, you can always just start it off like 1, 3, 5, 7. You know, and that'll help you to see what D is, what A is. Okay. How about this crazy one?
Okay, so it says x coordinate of 1. Do I need to sub in 1 for ln 3x minus e to the minus 2x?
I'd say yes, but it seems like it's not worth 6 marks, and that maybe you have to get the 1 yourself. You can't use the 1. A curve has this equation, the equation of the tangent. No. Yeah, you're right. Okay, what do you sub the 1 into?
Sorry. Into the x value.
Yep.
Yeah, I did that. I didn't really get like a nice number.
What would it be as an exact value?
It would be ln 3 minus e to the minus 2.
Yeah, if you put that into your calculator, you should get the same decimal number you got, and they want the answer in terms of e and ln, so they want an exact value. Okay, what do we do next?
Okay, so y equals mx. Is that like y equals mx plus c? So does that mean that if I differentiate ln 3 minus e to the minus 2, it'll give me what m is?
It'll give you 0 because this is just a decimal number. This is the y coordinate.
Yeah.
What we're aiming towards is this. This is just a very fancy y equals mx plus c. How do you get equation of the tangent?
Do I need to find the difference between two coordinates and also sub them in to get what c is, or
you're thinking like GCSE, which isn't bad because it requires some GCSE. Equation of a tangent. How would you find m? How would you find c?
so I'm guessing differentiate out y.
Yep.
So if I do dy dx, that will be. So I think that'll just be plus 2e to the minus 3.
Plus 2e. A few things. Hang on. It would be plus 2e to the minus. No. E stays the same. So to the minus 2x. The derivative of e to the x is e to the x. What is the derivative of the function inside the function?
Minus 2.
And what do you do with that?
Make that to the power of 2e.
Times by minus 2.
Times by minus 2, okay.
What is the derivative of ln 3x?
Ln 3.
Correct. Ln 3 is just a number. What's next?
So first of all, times 2e times minus 2. 2e to the minus 2x times minus 2.
Okay.
Is that just going to be minus 4e to the minus 2x?
Yep.
And so, is that equals to 0?
That's at a stationary point. We're trying to find the gradient at this point. What we have now is a gradient function.
Oh, do I need to sub in 1 now?
Yeah.
And so that will be... Yeah. I didn't get an exact value, so shall I just leave it like that?
So what would it be getting an exact value for it when you sub in 1?
It would just be ln 3 minus 4e to the minus 2.
Yeah. And so what you can do is check your answer. So ln 3 minus 4 e to the minus 2. So it gets us this value, 557. I just want to, shift d by dx. We originally had ln 3x minus e to the minus 2x, and the x value we're subbing in was 1. Syntax error, where'd I go wrong? I have to close the bracket. Oops. Oh, we're not right. Ln 3. Oh, that's because I removed the x when I did that bracket. Hang on, how do I get up there? There we go. Ln. Am I putting that in right? Ln. No. Bracket's in the wrong place. Sorry about this. So ln 3x and then minus e to the minus 2x. Maybe our derivative isn't correct. Let's say ln 3x, yeah, minus e to the minus 2x, and then we sub in x equals 1. So this is what our gradient should give. This is not what we're getting. Let's check this m. Okay, so y equals ln 3x minus e to the minus 2x. Derivative of this function. Derivative of ln 3x. So I believe that is ln 3.
Would it be 2x e to the minus 3x? I don't know.
No. Why am I wrong about that? So that would be... So the derivative... that's why. The derivative of minus e to the minus 2x is just going to be minus e to the minus 2x. It just doesn't change.
All right.
But you do have to change to times it by minus 2, though. The derivative of the function inside the function. And so what do you get there?
ln 3 plus 2e to the minus 2x.
Plus 2e to the minus 2. And then we sub in the 1. And that's just to the minus 2. So now let me put this one in and see if we get the same decimal. Ln 3 plus 2 e to the minus 2. 1.36, that's not the same. Did I put it in right? What am I doing wrong? I want to check max scheme. So dy dx, what is this? Y equals this. Dy dx is equal to 1 plus 2 over e squared. So they're saying it is 1 plus 2e to the minus 2. They're saying it is 1 plus 2e to the minus 2. So we have the 2e to the minus 2. But they're saying the derivative... Oh, God. Sorry. Andrey. Okay. These papers are sample papers. I was assuming that this is ln 3 of x. They need to put a bracket. It's ln of 3x. I think.
Oh.
Come on, man. All right. So this ln 3 should just be 1. Is that right? All right. All right. What is next?
So that's our gradient.
Yeah.
Does that mean that we need to somehow make it look like e squared plus 2 over e squared?
Yes, and that is equal to e squared plus 2 over e squared. That's because 2e to the minus 2 is 2 over e squared. They did e squared over e squared plus 2 over e squared, getting 2 plus e squared over e squared.
So, okay, so we've got the gradient.
Mm-hmm.
Now, when it says like minus e squared plus 3, is e squared plus 3 over e squared plus ln 3, is that like the plus c, just those two together?
Yes, so that whole thing there is plus c.
So does that mean that I now need to sub in my value for x, which is 1, and my value for y, which is ln 3x, or even so ln 3x minus e to the minus 2x.
Y is without the x's, the y coordinate.
So also y is ln 3 minus e to the minus 2.
Yeah. And what would you sub them into?
Would I do? Oh, if I do if I sub it into the top equation, like where the curve has equation y equals ln 3x minus e to the minus 2x.
No. You're trying to get c. How do you find c?
I usually just sub in like the gradient, the x and the y value, and then the final value is c.
But into what? You sub them into what? Think of GCSE. So you have a coordinate 1 is 3, gradient is 2. Find the equation of that line. It goes through 1, 3, has a gradient of 2.
Yeah, when I just do 3 is equals to 1 times 2 plus 2.
1 times 2 plus c. Yes, you sub it into y equals mx plus c. I think you were saying you sub it into that one. Okay,
Yeah.
so sub these into y equals mx plus c.
So that would be ln 3 minus e to the minus 2
Mm-hmm.
equals to 1 times e squared plus 2 over e squared.
Mm-hmm.
Plus c.
And when you solve that, what value do you think you'll get for c?
Minus bracket a half. Sorry, not half. Sorry, bracket, and then like e squared plus 3 over e squared.
Yeah.
Plus ln 3.
Yeah. And how do you get the final mark?
Do I just write all of that? Do I just then finally do y is equals to e squared plus 2 over e squared, etc.?
Yeah, and don't forget the therefore or something like that.
Yeah.
So y equals, and then that whole thing. Just want to see this mark scheme. It's not perfect. Let's see. You find, so you sub them into this, or y equals mx plus c. And so this bit here is the bit that's not correct. It shows logical progression. There's only one mark left at this point. A real mark scheme will say, they have to then do therefore y equals, and then all of this. If this is worth 1 mark, and there is only 1 mark remaining, then there's no marks for actually rearranging this C equation.
Okay.
Yeah. And what might make it a bit easier is, y equals mx plus c. Therefore, c equals y minus mx. So if it's the type of thing that you have to find c for, that you can't just show that, y minus mx might be a little easier than y equals mx plus c to find c. Let's see. Equation of a tangent. Find the gradient, find the intercept. The gradient, you get dy dx, sub in your x value, and then your intercept, you need to sub your x value into the original, sub in x and y and c into y equals mx plus c, and then you get your c value, and sub them both into y equals mx plus c. Any questions there?
No.
Okay. So they should have had a bracket like that. I was assuming it is the way you were as well, ln 3x. I'm really not a fan of these sample papers, I have to say. Okay, question 4.
Okay. So I think here is where I need to do something like so when it says x equals to 7 sine t plus minus 4, I think I need to solve for t.
Yeah.
And so would that just be arc sine of x plus 4 over 7?
You would think so, but you would lose the negative numbers, I think, if you did it that way. Is there any clue you get from what you're aiming towards?
Oh, so x plus a squared plus y. So does that mean that when I factorize it, it should be like x squared plus ax plus a squared?
Maybe. That's not what I'm getting at, though. Make sine t the subject.
So that would be x plus 4 over 7.
Make cos t the subject.
Y minus 3 over 7.
Minus 3 over 7. You have to do something that eliminates sine t and cos t. Any ideas there?
Oh, do I do I not do arc? Oh, am I meant to like arc sine one and then sub into the other or something? Or?
So that's what you would think, and you would get cos of arc sine of problem is, I believe you'd still have it. No, you wouldn't. You would lose the negative things. This is what you do.
Sine squared.
Square both sides, and then you add.
So that would be 1 equals to x plus 4 over 7 squared plus y minus 3 over 7 squared.
Yeah, and I believe that's what they that's in the form that they wanted. Is it? No, I think you had to
Oh, do I then need to?
just get rid of the denominator, I think.
Yeah. So do I then just? Can I just do 7 is equals to x plus 4 squared over plus y minus 3 squared?
I believe it is 7 squared equals
Yeah.
x plus 4 squared plus y minus 3 squared. And in fact, they wanted the 7 squared on the other side. It's because it's a fraction, everything is squared. They're both squared. And so, let me just, will this work? Yeah. And so you just put the equals 7 squared on the other side. Oh, what is A? What is B? What is C?
A is 4, B is minus 3, C is 49.
It's 4. Yeah.
Oh, is that like a circle equation?
Yep. Well done. Okay. B.
Do I need to just put it into my calculator?
Let's give it a go. Yeah. See how this thing goes. It's parametric. No. It's how do we deal with this thing?
Would I put in like 7 cos of?
Yeah, you would have to change it to parametric if you're using parametric equations. Exit. I think it's type F the param for parametric.
So yeah. Oh, and then when I've got parametric, do I then just put in like 7 sine?
So yeah, you have the xt1 and yt1. So the x is the first one.
So that'll be sine, but that's all. I don't get what I need to put in for t.
I think you just press the x thing and it'll come up as t.
Yeah. 7 sine t minus 4, and then 7 cos. Yeah, I got the same sort of curve sketch.
Okay. Endpoints.
When this is endpoints, is that just like the coordinates of where the circle?
Yeah.
About 3, 4.
About 3, 4. I just want to see, is there anything this can do? Maximum? Does that do anything? Shift graphical solve minimum. No, let's actually do this properly. So this one is 1, 2, 3 across. Okay, so we have our sketch. How would we do it using the other one? Using the one we found?
Would I sub in the values for y and x into the?
No. You said it was a circle.
Yep.
What's its center? What's its radius?
Oh, so its center is -4, 3, and its radius is 7.
Yeah. Equals 7. And so if we go back, so my thing is if I do shift view window, let me choose standard. Maybe it'll be more square. It just doesn't look like a circle because the way the axes are done. So if that is a center of -4, 3, then what? And a radius is 7. Then what are the end points?
Sorry, say that again, please.
What are the coordinates of the end points? Let's say what is the x coordinate? If the center is at -4, 3, and the radius is 7.
So -4, 3. Is that just like -4, 3 plus 7?
So if the radius is 7,
Yep.
what is the coordinates of the end points?
So the center is -4, 3.
Mm-hmm.
Will the endpoints be 3, 3?
Yep.
Oh no, and -11, 3.
Yeah, that's 3, 3. That's -11, 3. And again, it's not very clear. How about up here?
It would then be -4, 10, and -4, 4.
That's it. And I hope that's what they mean by endpoints. Usually you would just say like the roots and intercepts and all that. -11, 3 and -4, 10, -4, 10. Okay, so we're good. C.
So the curve is C. When it's this curve, is that like the circumference of the circle?
Correct.
So that's pi diameter. So would it be pi times 14?
Yep. Leave your answer in terms of pi.
14 pi.
I believe that's 14 pi. Quite a strange question. Hold on. So there's something we didn't take into account. The domain and range. -11, 3 is one end. The other end only goes to pi over 3.
Right.
So you have to... So what are the coordinates you get? Hang on, so that's t. Okay. So what do you get when you sub in pi over 3? into this equation?
7 cos pi over 3 plus 3.
Yep. And calculator, what value is that?
That will be 13 over 2.
Okay, I'm doing the sine one. Minus 4. So minus 8 plus 7 root 3 over 2. Minus 8 plus 7 root 3 over 2. And what was your one?
13 over 2.
13 over 2. Let's take a look. So 13 over 2. 7 root 3 minus 8. That's the same value? Yep. So our circle actually only goes from there to there. Okay. So it's only part of a circle. And you have to find the circumference, like the arc length of this bit. How do you find length of an arc?
R theta.
R theta, yep. And so, what is R?
7.
And what is theta?
Would it be like 90?
I don't think so. Hang on.
Okay.
If I just sketch it. And these are what your test is going to be based on, or a real example?
Yeah.
Okay. So this would have made a full circle. The center is minus 4, 3, so it's about there. And so theta, I'll use black, I'll use blue. So theta is the angle here. This is 7, this is 7. Is there some easy way to find this arc length from minus pi over 2 to pi over 3? To find so 14 pi is here. The arc is 5/12ths. So it's 14 pi times 5/12ths. How do you know it's 5/12ths? Is that because where does 5/12ths come from? Use the fact that the arc is 5/12ths of the circumference. Do you know where the 5/12ths comes from?
No.
These, like, it's worth what, 0 marks. It's worth 0 marks to know that it's 5/12ths. Is that because from minus, so what's, so a half plus a third? No. Whatever. You missed out the last mark. I don't know where 5/12ths comes from, and you don't need to know. Well, I suppose in this test, but not in the real exam. Let's see. But big picture. Anytime you have parametric equations and it's sine and cos, you have to, rather than go arc sine or arc cos, you have to go higher up. So you have to go square them both and add them. And that's how you eliminate t. Sine squared t, cos squared t, you're left with just 1. It's very common. Sometimes you might have sine squared and cos cubed, and so you'd have to get them both to the power of 6, something like that. Make those equal to each other. That makes a circle. You can use graphical calculator. It might be a bit misleading because this is a circle, but the y-axis is much more squashed in than the x-axis. Is a different scale. I could try, let me just see. Scale for that one is 1. Scale for this one is also 1. Yeah, I won't mess around with it. So this is representing a circle, but it's just the x and y are different scales because it's, landscape. The x-axis is much longer than the y. And so you can just use the equation you got to show that's a circle. Center -4, 3. Use that to get your endpoints. The bit about the the domain, we should have subbed in minus pi over 2 to get one endpoint and pi over 3 to get the other endpoint. But then the bit about finding the arc length, you don't need to do that bit. So any questions there?
No.
Okay, let's see. We can practice those sometime. The coordinates of AB. Okay, how about this?
I think what I need to do here is just do square root of -1 squared plus 7 squared plus k squared plus square root of 4 squared plus 1 squared plus 10 squared equals to 5 root 5.
Plus k squared plus square root 4 squared plus 1 squared plus 10 squared equals 5 root 5. Find the possible values of the constant k. So how do you solve that then?
Just solve for k.
How do you solve for k?
Put into my calculator.
Will it give you both in the graphical calculator?
Yeah, I think it does, yeah.
Okay, that's fine. And so you can see this is worth 1 mark. One of the answers will be worth 1 mark, and the second of the answers will be worth 1 mark. There'll be 2 values because k is squared here. I just want to quickly, I'm breaking up a lot, but
sorry, do you know how to get it back to it being x rather than t? Because right now I've got it stuck in the parametric.
just go to type, change it back to y equals.
I've got it on my on on the run matrix.
Yeah.
It's like there as well.
Did you go to your graphical bit and go to type and change it to
God equals.
y equals?
Yeah, I've done that now and then. Yeah, thanks. It works now. Yeah.
Okay, great. Sorry. If I just go back a second. Yeah. No. Makes an attempt to solve the equation. Yeah, wrong. This is worth 1 mark, this is worth 1 mark. They're saying they're both worth. Anyway, B. I'm sorry, the larger value was 18.
And A is so the coordinates will be -1, 7, 18, I think.
Yeah.
And it says in the direction of OA. So that means from the sense, that means from like 0, 0, 0.
Mm-hmm.
Oh. Am I doing 0, 0, 0 plus -1 plus 7 plus 18?
I think so.
So would that be -1 plus 7 plus 18?
Seems too easy for 3 marks though. Are we reading this right? For the larger value of k, so k is 18, find the unit vector. What is
the number. Do I need to then do -1 squared plus 7 squared plus 18 squared?
No. That's the magnitude. A unit vector. Unit vector is when it's... Oh, I forget. You have to... Yeah, sorry, you do have to do Pythagoras, I think.
And I got root 374.
Okay, and what do you do with that?
Vector in the direction of OA. So do I say OA equals to root 374?
No, that's the magnitude. A unit vector, I think it's something like root 374, and then it's times these things all over root 374. Unit vector, I just don't remember. So root 374, that's it. It's in terms of I, j, and k. So it is 1 over root 374, and then it's in terms of I, j, and k.
So would I need to do like -1 divided by 1 over root 374 for like the first one?
This is the unit vector. So
Oh, right, okay.
the unit vector for this is like 1 over the magnitude of OA. And then here is the I, j, and k of OA.
Yeah, okay.
That is known as the unit vector. Okay. Any questions there?
No.
Vectors. Is this... What year is this test for?
I don't know.
Okay. Let's see. Let's try this one.
So it's an 8 marker. I think with this one I need to integrate. I need to first of all integrate. So should I first of all do... Okay, so should I first of all do e to the power of 2x times e to the power of 2x minus 1 to the power of -1?
You could, yeah. There's a much easier way, though. Okay. The numerator is the derivative of the denominator. Do you know anything about that?
Does that mean I can just cancel it down, or?
No, it means, I believe, the integral of this is ln e to the 2x. Or it's ln 1 over e to the 2x. Something like that. Let's see. It is ln e to the... That's ln e to the 2x minus 1. The denominator one. If the denominator... Sorry, if the numerator is the derivative of the denominator, then it is... The integral is ln of the denominator.
Okay.
And that comes up a different thing in integration. Okay, what's next?
Is that the integrated form or not yet?
That is the integral, yeah.
So now I've got... Oh, do I now need to sub in ln b for x? And then... Oh, sorry.
Yeah, correct. You can make your life a bit easier, though. Do you know what ln e to the power of 2x is?
No.
It is the same as 2x ln e. You can bring the... So that's like ln is just a log, so you can bring the power to the front.
Right, yeah.
Put into your calculator ln e.
One.
Correct. And so what is this
Oh,
infinite?
2x minus 1.
2x minus 1. And hopefully that will make your life much easier than subbing it into...
Yeah. And now I think if I just do, I think I can just put this into my graphical because my graphical gives me the answers. If I just do 2 times ln b minus 1 and then minus 2 times ln 2 minus 1,
yeah.
ln 4. Yeah.
Ln 4. I'm just concerned, hang on, showing each step in your working. So if they've explicitly stated that, then I think we have to show each step.
So do I now need to do what? So do I need to just put in? Do I need to then first of all find the value of 2 ln 2 minus 1?
Let's do it. Let's keep it exact for the moment.
Yeah.
And let's try to make b the subject. Let's try to solve for b.
Should I do ln 4 plus 2 ln 2 minus 1?
Yeah.
And then I should do all of that plus 1 and then divided by 2 equals to ln.
Yeah. That's ln b. Simplify.
So ln 4 plus 2 ln 2 over 2. Oh, and then that will just become, yeah.
What would it become? There's two ways of going about it. Make everything ln. So this is 2 ln. Turn that into just 1 ln.
Will that just become ln 1?
It would be ln 2 squared.
Ln, oh, yeah, because you square. Okay. And so that would become ln 4 plus ln 4, which would become ln 8.
No. It would be.
No.
It would become ln 16 or 2 ln 4.
So 2 ln 4 over 2 equals ln b, which will then become, oh, and then that'll become ln b equals to ln 4.
Yeah. So what is b?
4.
So there we've shown every step of our working out. Keeping in mind, so right from the very beginning, integral ln, no, what is this fraction? E to the 2x over shift e to the 2x minus 1. Down here is ln 2. Up here is ln, we'll call it x, because I only have x as the unknown on this one. That whole thing is equal to ln 4. Shift solve. Lucky 12. Should have gone with lucky 7.
And this gives the answer.
And it gives us... I'm getting x equals 7. Did I put that in right? Ln x, ln 2, e to the 2x. Let me try. Shift solve. I don't know. Maybe graphical will have an easier time with it. I'm getting 7. Are we wrong then? Maybe we're
It,
wrong.
no, is it because it's interpreting like because we've got two? Is it because there's two x's and we've got b and x here? Does that
No. I think we went wrong somewhere. Let's just take a quick look. So why was this integral ln e to the 2x minus 1?
So 2x ln e minus. So we move the power to the front.
No. So where did this come from? Step 1.
We did so because we did e over e to the power of 2x over e to the 2x minus 1, and so we just able then to turn it into ln e to the power of 2x minus 1.
Yeah, sorry, I think I'm dead wrong. Am I? No, that's right. Sorry. The numerator is the derivative of the denominator, therefore it's just ln denominator. Ln. I think I know. Hang on. Sorry. Is it ln? That's what it is. It's the whole thing in the bracket. Is that right? What is ln 1? Maybe yeah, that's what it is. Ln 1 is 0. So we don't have this minus 1. That's what happened. So we don't have that extra minus 1 throughout. Sorry, there should be a bracket. It's the ln of the entire denominator. So
Okay.
it's not ln e to the 2x minus 1. It's the ln of the whole thing. I just have to quickly show you. Ln e to the 2x minus 1. How do you split this up into separate lns?
Ln e to the 2x minus ln
E to the 2x. Hang on. No. You can't split this up. They're not times each other. Oh, we need to. Let's see. So you would then just sub in ln b and ln 2. What is e to the 2 ln 2?
Syntax error. 4.
It is 4. It's because it's the same as e to the ln 2 squared. Very good. So that is ln 4 minus 1. What about the ln b part? Ln e to ln b.
So 2.
And you can use this one to help us.
Ln 3. So we're doing e of what are we trying to get b as? Sorry.
So e to the 2 ln 2. That's the same as e to the ln 2 squared. You just move the front to the power.
Oh, so 2 ln b will be the same as ln b squared.
Just b squared. So, okay, so e to the ln b squared. And so what does that simplify down to?
Oh, just b squared then?
Yeah, just b squared. And so that's where we... Yeah, sorry. It was just that thing needs to be in a bracket. It's the ln of the entire denominator. My mistake. But anyway, calculator helped us. So we thought it was 4, but it was actually 7. And so you could always go back and get that. Let's just check. So b is 7. Yeah. You would just go through the same steps and solve it. Any questions there?
No.
And let me just see. A level. So this has year 2 stuff in it, I believe. Whoops. Okay. Sequence. Let's try this.
Okay. So if x1 is 4, does that mean that a is 4?
Yeah. That's not helpful though. How'd you get x2?
By subbing x1 into the formula.
Yeah. What do you get?
Am I subbing 4 into... Oh, will that be like... So will that be like P 4P minus 9 or something?
Correct.
And then for x3 I just sub in 4P minus 9 into 4P minus 9.
Into this again.
So that, so 4P minus 9 times P minus 9.
Yeah, and what will you get?
I'll just get 4P squared minus 9P minus 9.
Yeah, actually that's exactly. Okay, part B.
Oh, so make it equals to 46 and then just make equals to 0 after.
Go on, solve it.
I got P's. So it says, well, I got two answers for P. I got 5 and minus 11 over 4. But it said find the value, so I'm guessing they want one answer. It says an integer, so P is 5.
Yeah, and C.
So for C, if I just put in, sub in 40, so do 46P minus 9, which will be x4.
Mm-hmm.
And then sub that into the same formula.
You found what P is.
So if I do, so P is 5,
Mm-hmm.
and so I'm now doing 5 times. I think I got some stupid answer.
How do you get x to x4?
So that would just be 46P minus 9, or 46 times 5 minus 9.
Yep.
Be 221.
So what is x5?
It will be. Yeah, I got 1096. That was too bad. Too like big to be right, correct?
Is that what you got the first time, was it?
Yeah.
Yeah, 1096. And if you remember iteration from GCSE, see I teach GCSE as well, so I always have this in my head. We said So 4 is our x1. Save that as answer. We said p was 5. So it's 5 answer minus 9. That's our x2, x3, x4, x5. Whichever way you like. Let's see. And sorry to be annoying, but I just want to check this mark scheme. X2 is 4p minus 9. And then you sub that in. Fine. Method mark is that. So this, no. Factorize for a method mark. That's a joke. Okay. So I'm just kind of making a note to myself because I want to go through. I was going through other like GCSE past papers just to make sure that this calculator stuff that I do is correct, because the teacher was saying teacher didn't let one of my other students use the 991EX calculator, the kind of simpler one. They said like that's not allowed in GCSE, and I had to look it up, and no, it is totally allowed, and it's like the you get full marks basically, if you just do that. Sorry, any questions about that previous one?
No.
Okay, 8.
So I just factorized the denominator first, 6 over thing, and I got 2x minus 1 times 2x plus 5.
And if I was a betting man, I would have bet that 2x minus 1 would be one of them. Okay.
And then do I just times the second fraction by 2x plus 5?
Yep.
And then that means that the denominator will be times by 2x plus 5.
Yeah.
And that will then become 6. So 6 plus 6x squared plus 17x plus 5.
Mm-hmm.
And then that will become simplified 6x squared plus 17x plus 11 over 2x minus 1, 2x plus 5.
Mm-hmm.
And I then need to do over, and then they want me to, shall I factorize that numerator as well?
Just give it a go.
And I got x plus 1 and 6x plus 11.
Okay, if I was a betting man, I would have thought it would be like 2x plus 5 or something, but let's take a look. Question 8. 6x plus 11, x plus 1, 2x plus 5, 2x minus 1. Okay, so I didn't get any simpler than that. Great. Any questions there?
No.
Okay. This graph. Yep.
I wanted to ask you yesterday about this. Do you know how to put in the modulus into a graph?
Yeah. I found it one time. Hang on. I definitely know how to do it in the simple one. So this is the h of x. So, oh, that's weird. Hang on, let me just check some. It says this is the h of x. Then they say the f of x. Okay, so that's just a misprint. They mean here the f of x and then the magnitude of the f of x. Graphical calculator. First things first, I'm the realist. Let's see. Well, we don't know, but let's just go for this thing. Option. Is it option? Press escape. How do you do modulus in general? Let's see. Menu 1. I think it comes under math, does it? Maths vector log AB absolute. It's this one, F3 absolute value. And so let's now go to graph.
Sorry, how? Oh, sorry.
Sorry. It's maths
Yeah.
and then abs for absolute.
Oh, thank you. Cheers. Yeah.
But I just want to see, is it available for this one? I don't see maths anywhere or absolute anywhere. Oh wow, you can actually draw the graph of the gradient function of the integral, all sorts of stuff. Okay, but it won't help you for this one anyway. They've designed this so it won't help. Okay, so what they want y equals the modulus of the f of x.
Modulus of the f of x. So they didn't give me what the f of x was, did they?
Sure didn't. What do you know about modulus or absolute value?
It's positive, I don't know.
Yeah. And so what's that going to do to some of our coordinates?
So, all right. So will it become like a becomes? Does a stays? Oh no, does a become -4 3? Yeah.
It stays.
And then b is 0 -5.
Y is the modulus.
Also 0 5.
Yeah.
And then c is 2 6.
Yeah. So 2 6 will be up here. This will be here. And this one stays the same. What do you think this modulus does to the graph? How will happen to the graph?
Oh, and so then it will become. So do I then just plot the new points that I've just got?
Yep. However, the positive stays the same. Yeah. Positive y stays the same. What will happen with the negative y's?
They'll bounce up.
Correct.
Oh no. Yeah.
It's like a reflection of just the negative ones. And so, okay, so my thing is terrible, but that's too terrible. It kind of bounces. That's the maximum. Goes down to there. Then that's normal. And then it bounces again.
Yeah.
Okay, that is y equals the modulus of the f of x. What is y equals the f of the modulus of x?
Does that mean that anything that's x just changes to? Does that mean that any negative x changes positive?
Yeah, so what are the new coordinates?
Will that become 4 3, 0 -5, and -2 -6?
Yeah, I think not though. I think not actually. Let me think about this. I think it's because when you put in 4, so let's say 4, maybe you're right. When you put in 4, you got this value.
Yep.
When you put in, okay, so what would the graph look like then?
Would it pretty much be like a full reflection? Apart from, oh, actually, no. So would So with minus 4, 3, 3. Oh no, the graph just like sort of turn the other way around.
Uh,
That makes-
only the positive bit would. So it would, the positive side stays the same. The positive x side stays the same. But then the negative x side. So let's say if you put in x equals -2, what y coordinate would you get?
If I put in -2, would I get 6?
Correct. You would get the same y coordinate as if you put in +2, because the modulus of -2 is +2. And so what you get is essentially it repeats. And so it's the same thing. So it's like a reflection in the y-axis of the positive bit. So this one is a reflection in the x-axis of the negative y's. This is a reflection in the y-axis of the positive x's. Because when you put in a negative x, you get the same y value as when you put in the positive x, because it becomes positive. Tricky stuff. Okay, and there was one more. 2f of x plus 3. There we go.
Oh, so does that just mean that for all the y coordinates, I need to just time? Yeah, that's not even modular. So all like that's just me doing timesing 2 and then adding and then minusing 3. So timesing 2 for the y coordinates and minusing 3 for the x coordinates.
Okay, so what's gonna happen to A?
Become -7, 6.
-7, 6. Okay, let me think about this. Because I think Bidmus is involved here. Maybe you're right though. So you multiply all the y coordinates. Yeah, I think that's right. How about B?
Would I do -1, -12?
Yep. And C?
Would I do -3, -10?
-10. So this is the new B. The new C is -3, -10. And then the new A is -7 up at 6. And so you would then just sketch it. So what does the +3 do? The x plus 3?
That just makes all the x's negative. No, not negative, but it just takes away 3 from all the x coordinates.
Yes. So basically the entire graph will move 3 spaces to the left, and then the times 2 on the outside.
That'll just multiply all the y coordinates by 2. Oh, and so does that mean that they could either go twice as high or twice as low on the graph?
Yes, correct. So it stretches it twice as high, twice as low. And so it ends up looking something like that. Hopefully. Let's see. Okay, so this is our y1. That's fine. All the negative y coordinates became positive, and the negative ones bounce off the thing, the reflection. So this one is like a repeat. It's like a reflection of the positive x in the y axis, and you put in your 3 coordinates. And then this one Minus 6, 2. Oh, yeah, that is what we... Is that what we said? Yeah, that's what we said. Hang on, minus 6, 2. Minus 6, 2. Did we do that somewhere? Minus 1, minus 12. Minus 3, minus 10. Minus 6. What did they do? Minus 6, 2. Is that correct? It moves the graph left 3 spaces. So if it moved everything 3 spaces to the left, then minus 4 would become minus 7. They said it's minus 6. That's not right. And the y coordinates were all multiplied by 2. This 3 they said became 2. Let me just... Clear attempt to move the graph to left 3 spaces. Clear attempt to stretch the graph vertically by a factor of 2. I think they just made a mistake there. I think...
Yeah.
Yeah. Because everything else is all right. Okay. Any questions about that one?
No.
Okay. Yeah, I think we're good there. Okay, question 10.
Do I need to put that equation into my graphical calculator?
By drawing an appropriate sketch, show that there's only one solution to the equation. And so how do you show that there's only one solution to the equation?
Is it that if there's only one root, then there's only one solution?
Yeah, it intersects with the x-axis at only one point.
Yeah.
How do you do B?
So just make it equals to 0, I think. And then I would do... So I'm solving... so if I do... Two over x minus 1 equals to e to the x.
Yeah, I don't know how this is going to work out. Okay. And so we're not even trying to make x the subject. We're just trying to get an x on one side by itself. Okay, yeah, go on.
Oh, actually, yeah, that's a good... Oh, shall I just then do, like, 2 over e to the x plus 1 equals to x?
Yeah. And make it look like their one.
And then just say 2e to the minus x plus 1, yeah?
Yeah. Or I should have put the x on the left side. Okay. Next part.
I think I just need to sub in 1 for all the x values. 1, 2, 3, and 4 for all the... actually, so... It's fine. So... Do I need to sub in like 1 for x1? Do I need to sub in 1 into the n value or the x value? Is the n value?
Yeah, just the n value. So you get x1. So
yeah.
How do we get x1?
2e. Oh, I'm getting confused, sorry. Yeah, just 2e to the power of minus 1 plus 1.
Not minus 1.
Oh, so that's... just 2e to the 1 plus 1.
No. X1, the way this works is this is like next x. This xn is previous x. What?
So that'd be 0.
It would be x0. What is x0?
Yeah. It would be shift e to the 0.
Andrey.
Oh no, they gave me the answer. Okay, so 2e to the minus 1.5 plus 1.
Yeah. What is that? 4 decimal places.
1.446.
That's 3 decimal places.
6.
That's 3 decimal places.
6.3.
Okay. X2.
Just do 2e to the minus ands plus 1.
Correct. And do yourself a favor, use that ands thing right from the beginning.
Yeah.
But you're right. Okay, x2.
And that would be 1.4709.
Next one.
It was going to be... Oh no. Sorry. So 250 to the minus. Sorry. X2.
Where is E on this calculator?
It's where ln is.
I see. Yeah. Am I right in saying, so you having to type in 2e to the minus answer plus 1 each time, is it?
Yeah. Oh no, I'm just from the previous thing. I'm just going where I put e to the power of, and subbing in the previous answer in.
So you see how I put 1.5 and pressed equals?
1.5. Yeah.
So now that is saved as answer. So I just put in 2e to the minus answer plus 1. Answer on this calculator is shift and then the negative symbol next to xq, bottom right.
Yeah.
I believe if I press up on that thing again and press equals again. No, that's giving me... how do I copy and paste that thing again? I'm just using simple calculator for this one. So remember I did this iteration before?
Yeah.
So try that. So initial answer is 1.5. 1.5, just press equals. That's now saved as your answer.
Yeah.
And then do the rest.
And yeah, it keeps on giving me the previous values. Yeah.
Okay, so that's x1. X2?
Would be 1.4709.
Yeah. X3?
1.4594.
X4?
1.4647.
Yes, and that's a much more efficient way of doing those. Question D. .
I don't know what the Newton-Raphson procedure is.
I believe this is a formula. It's how your calculator gets its answers when you use the solve function. Did I not see? Was at the top of the other paper the formulae? Let me open up this first paper. I gave you this formula sheet. Did I imagine that? Was it on the mark scheme? Cam downward. This is the mark. No, won't it let me? Oh, okay. I thought I was looking at it earlier. Formula booklet L Maths Pearson, which is at Excel. Find the Newton-Raphson method. Okay. This.
Okay, so x to the n. When this is using 1 point, does that mean I need to use 1.5 here?
Yeah.
So does that mean that f of x? So am I doing 2e to the minus 1.5 plus 1 as the numerator? Oh no, or am I doing 1.5 minus 2e to the minus 0.5 plus 1, and that's the numerator, and then I need to differentiate that to get the denominator?
I believe that this is not the f of x, that this is not the g of x. What is the function?
It's not the g of x, is it?
It is.
It is, okay.
So this is like after we rearrange that thing. So this is like x equals, but it's not. It's not the g of x, yeah.
So will that be 2 times x minus 1 to the power of minus 1 minus e to the x?
Yep.
And that differentiated will become. Oh no, I need to expand that first. So that will become x to the. Will that become actually? Sorry.
You have to the power of minus 1, which locks it into bidmus. Don't expand it.
Don't expand it. Okay.
Try differentiating without expanding it.
Am I moving minus 1? Am I doing minus 1 times 2 here?
Yeah.
So minus 2, and then x minus 1 to the power of minus 2.
Yeah.
Minus e to the x.
Almost. What is the derivative of the function inside the function?
Will that be just x to the minus 2?
No. Derivative of function inside function. Derivative of x minus 1.
Oh, 1.
So you times that first one by 1, which doesn't change anything, but just for your own sake. Okay. So let's use that.
So am I now doing 2 over 0.5 minus 1 minus e to the power of 0.5? Actually, sorry. So 0.5 minus that as the numerator over.
Hang on, start again. What are you doing?
So am I doing 0.5
Where does that come from?
x to the m?
Uh,
Also 1.5.
okay, go for it. Go for it.
So am I doing 1.5 minus 2 over 1.5 minus 1 minus e to the 1.5 all over minus 2 times 1.5 minus 1 to the power of minus 2 minus e to the 1.5.
Yeah. 0.5. And that whole thing is over minus 2. Okay, put that in your calculator.
Yep. I got 1.4614.
Sounds good to me. I'm just up here. Hang on. Shift E to the 1.5. And I just want to try something. If I put down on the bottom, shift the derivative of 2 over x minus 1 minus e to the power of x, and what you get when you sub in 1.5. Is that the same number?
Yep.
Okay, so I've kind of confirmed it with our calculator. Who knows if the mark scheme like wants you to show that and all that stuff. This looks like mark scheme. So then you sketch it. They did it a different way to sketch. Okay. One root makes an attempt to rearrange the formula. So you make x the subject. Yeah. Those were our x values. And then the last one is 1.461. Yes, as I suspected, there's no extra marks even on this mark scheme for finding. Oh no, there's an accuracy mark, no method mark. Okay, well you were able to do it. Let's see. So sketch, show that it has one root. Fine. Show that it can be written in the form that this is an iterative formula. What they do then is they change x into xn plus 1 and all the x's on the right side into xn. And that's where that comes from. So you don't necessarily make x the subject, you just get one x on one side by itself and you can have x's on the other side as well. That changes it into an iterative formula, which you can use to approximate answers, and that's how your calculator, well anyway, that's okay. Iterative formula, use answer. So all the xn's, replace them with answer and just save x0 as the answer first. Makes it much quicker and easier. Use simple calculator for that. And then this Newton-Raphson method formula, look it up and yeah, sub in the thing into the derivative. Any questions there?
No.
Okay, let's see. I'm glad that we got to practice that iteration. There's two things I want to practice. One was the fractions. Is that the last question on that paper or something? sequence. Need to know. Okay, how about this?
Okay. Okay, so here I'm doing so that will be the same as 1 plus x over 1 minus 2x to the power of a half, and then I think I need to take that up, and that'll be 1 plus x times 1 minus 2x to the power of a half,
Minus half.
minus a half, sorry, yeah.
Mm-hmm.
Do I then expand the brackets for the right bracket?
Can't expand the brackets because of bidness, or not easily at least. Formula sheet.
Oh, will I do
Mm-hmm.
the binomial expansion separately?
Yeah, binomial expansion. Maybe I don't have. Kind of do. Yeah. Okay. How do we do this?
So do I now need to do the expansion separately?
Yeah.
So shall I start with 1 plus x first?
No.
Cool. Shall I start off with
One,
first
one,
then?
1 plus x can't be expanded because it has no power, because to the power of minus a half, because of bidmus, is connected only to the second bracket. And so you can only expand the second bracket if I understand your meaning. So how do we
And
go about
so
this one?
will that then become 1 plus minus a half x, or even minus a half minus 2x?
Let me think about this. Okay. 1 plus minus 2. What is n?
Minus a half.
So that is minus a half times minus 2x. Is that right?
Yeah, I think so.
Let me think. Did we have to? Yeah, I think. Okay. Hang on. 1 plus minus a half minus 2x. Let me make sure. Don't even know. Hang on. What question? This question 11. Is this the right exam mark scheme? Maybe it's not. Hmm. 1 plus, yeah. Sorry, we're good. Okay, go on.
Okay. So, and then do I do plus, so minus half times minus a half minus 1 over 1 times 2
Hang on. Minus a half times.
minus a half minus 1
Yeah.
over 1 times 2,
Yeah.
and then that will just be times by minus a half Oh no, sorry, minus 2x squared at the end.
And how do I write minus 2x squared?
So bracket minus 2x close bracket squared.
Well done.
And so that will then become 1 plus x, and then uh, plus. So I got 1 plus x plus 3 over 2x squared.
Yeah. Okay, what do we do with that?
Times that by 1 plus x.
Yes.
And so that will become 1 plus x plus 3 over 2x squared, plus x squared plus 3 over 2x cubed. And then I think my final answer will be 3 over 2x cubed. Plus, and then, sorry, plus 5 over 2x squared,
Mm-hmm.
plus 2x plus 1.
And what does this mean here?
It says up to and including the x squared term. So does that mean that it will just be 5 over 2x squared plus 2x plus 1?
I believe so. I just want to check. Don't think you'd get penalized for exceeding that. Let me just see. Dot dot dot. Yeah, fine. Okay. Part B. State the values of x for which the expansion is valid.
Am I just factorizing x there?
Nope.
Is that only like magnitude of x is smaller than?
Yeah.
Oh, magnitude of x is smaller than 1.
What is x in R1 though? You didn't sub in 1x every time.
I subbed in minus 2x.
Yes. And sub magnitude of?
Would that be x is smaller than minus a half?
Yes. Magnitude of minus 2x. Is that magnitude of x is smaller than? Has to be. That doesn't seem right. Does this sign flip? Because it's.
Oh, when you divide by negative, doesn't it flip?
It has to be greater than minus a half. Let me just see. Yeah, magnitude of x greater than minus a half. Let's just take a look. Magnitude of x is less than a half. It's in between minus a half and a half. This is why you have to do these things out fully. Can't be negative. Can't be negative. And so essentially what we were looking at here is the magnitude of x has to be greater than minus a half, but also the magnitude of x has to be less than positive a half. And so essentially it has to be between minus a half and plus a half.
Okay.
And there's nothing wrong with writing it out fully, like technically I did teach you and which you never wanted to do. Sorry, that's not magnitude of x, that's just x. Okay, question C.
Am I subbing in 1/100 into my binomial expansion that I found?
No.
Okay.
Into this, and then you get that.
Okay, so if I do just 1 plus 1/100, and then square root of 1 minus 2, 1/100. And I'm guessing I'll just do in the end equals to 100 root 2 over 140.
Yep. And part D.
So am I just subbing now? Am I subbing in 1/100 into my expansion?
Correct.
And so that'll be and it says it wants you to find hence approximation to root 2. So give your answer to 5. Am I just giving my answer that I just got to 5 decimal places?
Yep.
1.02025.
2.5, and if you put in one, hang on. Okay. Let me think about this. X equals into the, and hence obtain an approximation to root 2. Does that give you an approximation of root 2?
Not really, no. I just root 2 is like 1.41 and stuff.
Well, it's an approximation.
Yeah.
Okay, let's take a look what this is about. You sub that in, you get that. And then D, you sub that into your thing, you get that. So this value that we got is approximately equal to that. There is one step we're missing. So you see how these two are approximately equal to each other?
Yep.
1.02025 is roughly equal to 101 root 2 over 140 is essentially what we just did. Make root 2 the subject.
I would get 140 times 1.02025 over 101.
Yeah. And do that to 5 decimal places, whatever.
Yeah, and I got root 2, yeah. I got 1414201.
1. And that's that one. Let's see. So binomial expansion. Use your formula. Don't worry about not using the formula. You're good. Very good for binomial expansion. This valid thing, I think it's just easier to write it out fully. Like x is between 1 and minus 1. And so this was minus 2x. And so you would times everything by minus 2. And then you would divide everything. Yeah, sorry, minus 2x is between 1 and minus 1. And then just divide everything by minus 2. 3, don't be thrown by that. They want you to put that in exactly into the original one. And then part D, sub it into your expansion. Your expansion is approximately equal to this one. And so you just make root 2 the subject. Bit unusual. I thought they would ask for percentage error, something like that. Any questions there?
No.
Okay, we did good. How much of this paper is left? 1